look around, choose your own ground. Long you live, high you fly, smiles you'll give and tears you'll cry. All you touch and all you see is all your life.
Hello. Good morning, everybody. I'm Chris Purcell. I'm the Vice President of Technology here at Vulcan, and I'm also one of the Board of Director members for Stratolaunch Systems. It is my pleasure to welcome all of you here today as we introduce a new project that is truly out of this world. In 2004, Paul Allen and Burt Rutan inspired all of us as they raced to win the Ansari X Prize. Spaceship One became the first commercially funded manned spacecraft capable of carrying 3 people to space twice within a 2-week period. Well, Burt and Paul have gotten back together to push that envelope even further. To set the trajectory, it is my pleasure to invite Mr. Paul Allen, our chairman and founder, to the podium.
Thanks to all of you for coming. This is a very exciting day for me. It's a great honor to be back working with Burt Rutan, a true genius and one of America's great aviation pioneers. He has already done so much to expand the possibilities of private space travel. There is no one else I would have as a partner in taking this next great step. I also want to give special welcome to my friend Charles Simonia, who's sitting right there. Back in our Microsoft days, we shared a passion for space, even slipping away from our work on the early work on the IBM PC to make a mad dash to Florida to watch for the maiden launch of the Space Shuttle Columbia. Charles is one of the world's very few space tourists, having made 2 flights to the International Space Station, and I was lucky enough to be in Kazakhstan to watch his launch in a Soyuz flight to the station. When I was growing up, America's space program was the symbol of possibility and aspiration, the affirmation that nothing was beyond our reach. I can remember myself as a small boy standing with my mother on our front porch as we tried to find Yuri Gagarin's Vostok spacecraft in the night sky. I immersed myself in the science fiction of Robert Heinlein, Arthur C. Clarke, that imagined what a future in space could bring. Like many children of that era, I dreamt of becoming an astronaut. My own youthful attempts at rocketry, like the literal meltdown when I tried to launch a rocket made from the arm of an aluminum lawn chair stuffed with propellants, were less than successful. And my nearsightedness dashed my dreams of becoming a pilot. But for me, the fascination with space never ended, and I never stopped dreaming about what might be possible. About 10 years ago, Burt and I started working together on a significant step forward for human spaceflight, Spaceship One. In 2004, Spaceship One, the Ansari X Prize, is the first privately funded manned spacecraft to travel outside the atmosphere twice in a 2-week span. We showed that private industry could play a transformative role in space exploration. It was incredibly rewarding to watch Spaceship One installed at the Smithsonian National Air and Space Museum, right between Charles Lindbergh's Spirit of St. Louis and Chuck Yeager's Bell X-1. The breakthrough technology that made Spaceship One possible has had a big life since the Smithsonian. It's now playing a key part in Richard Branson's space tourism business, Virgin Galactic, which is already taking reservations for suborbital travel. At the same time, our national aspirations for space exploration have been receding. This year saw the end of NASA's Space Shuttle program. Constellation would have taken us back to the moon, has been mothballed as well. For the first time since John Glenn, America cannot fly its own astronauts into space. With government-funded space flight diminishing, there's a much expanded opportunity for privately funded efforts. Since the success of Spaceship One, I have thought a lot about how to take the next big step. a private orbital space platform business. Today, we stand at the dawn of a radical change in the space launch industry. Stratolaunch will build an air launch system to give us orbital access to space with greater safety, flexibility, and cost effectiveness, both for cargo and manned missions. We have plenty and many challenges ahead of us, but by the end of this decade, Stratolaunch will be putting spacecraft into orbit. It will keep America at the forefront of space exploration and give tomorrow's children something to search for in the night sky and dream about. Work has already started on our project at the Mojave Spaceport. Now we'd like to roll the video. Roll the video.
Pretty neat, pretty neat. Stratolaunch Systems is developing a revolutionary approach to space transportation, an air launch system that will have the capability to deliver unmanned and payloads and manned spacecraft to orbit with greater safety, cost effectiveness, and launch flexibility. As you saw, any orbit, any time. It's a natural evolution of the innovative designs created by Burt Rutan for Spaceship One. And when Burt thought about the next step in space travel, it's only fitting that he reached out to his partner, ex-prize partner, Paul Allen. Burt Rutan is the founder and ex-CEO of Scaled Composites and a founding member of the Stratolaunch Board of Directors. A renowned aerospace engineer, Burt is noted for his originality in designing light, strong, energy-efficient aircraft. He is famous for his design of the record-breaking Voyager, which was the first plane to fly around the world without stopping or refueling. And if I recall, 25-year anniversary, next week. Including Spaceship One, BERT has 6 aircraft on display in the National Air and Space Museum in Washington, D.C. It is my pleasure to welcome the magician of the Mojave, Mr. Burt Rutan, to the podium.
Thank you. You know, Paul and I were chatting while this video was going on and pointing out there's a very large mistake on the video. And also right here in front of us is a very large mistake. And that is, you should never show this airplane or a model of it without right next to it showing an airplane that we know how big it is, like a little 747. You don't see the perspective. You don't appreciate what the wingspan of 385 feet actually looks like unless you include in those drawings or video or in real life soon how big an airplane this is. I have been working on issues related to launching rockets that go to space for almost 25 years now. We built components, wings and tails for an air-launched orbital vehicle back in the 80s. In 1991, I was invited to be a part of a very small group. I think there were just 5 of us, including Max Faget, Cadwell Johnson, myself, and a couple of other pillars of the space business, to go off together quietly in Houston and talk about requirements and benefits and what could happen by launching very large rockets from airplanes. There was always in those days a focus, well, you do something different to a 747, like maybe put 2 of them together and a little wing between. And I remember thinking, gee, that's really a stupid idea. If you're going to carry, in those days we were looking at carrying well over 1 million pounds up to launch. If you're going to do that, you have to do it with a dedicated airplane specifically designed for carrying those big payloads. We even looked at the airplane having rockets on it so that it could point the payload uphill before releasing it. But I dug out when I knew there was going to be a press conference here and looked at my old model list and found in 1991 I had a model 204 and 205 that showed airplanes that were specific, dedicated designs for this purpose, but were all of them used leftover parts from, systems from 747s. They used landing gear, engines, hydraulics, actuators, and electrical systems, and so on. And to think that my small company, in those days, there were only about 38 of us, I think, or 40, somewhere in that time period, could even dream about building such a big airplane. I realized the only way that we could play in that would be to build the airframe structure, and that we would have to use systems that were already existed and were proven. Just about every year or two since that time, that 10-year time period, we've had another requirement come up that required us to do some preliminary designs of systems that could launch very big boosters. And when it surfaced that Paul wanted to do this and wanted to work with us, it was absolutely warmed my heart, because this guy has been the absolute perfect team member and customer to work for. We got together and in 2000 to do Spaceship One. I remember talking a little bit about it here and there, and I wasn't ready. And Paul and I were talking about orbiting airplanes that provided telecommunication links to cover whole cities with broadband. This is before the fiber came in. But I remember I asked to talk to Paul, and he said, come by my office. And he had a nice little lunch for me there, which I didn't eat any of. But I had just thought about this idea of having a safer reentry by feathering the airplane for reentry. And I looked at him with some confidence now. Essentially what I was saying, I don't know, I may have even said it, is that if I had the money, I would put my own money in this. And Paul reached out, and he said, well, Bert, then we're going to do it. And that was the extent of my money search for Spaceship One. Wow. It doesn't get any better than that. Another thing that's very significant, if I had done this program for Michael Griffin, were you administrator in 2000?
I was the administrator in the next second Bush administration.
I would have been forced to not try something like feathered reentry because, well, the X-15 didn't need it, so you cannot take the risk.
If you were doing something for me, you would not have been forced not to use a feathered entry.
The beauty of this is Paul didn't challenge our own decisions on what risks to take, and I believe strongly that the decision on what risk to take should be taken by the risk takers, not by the top managers. And I think that's been so important to our success in developing some 45 airplanes since I started this business. Looking forward to doing that again and working again. Our relationship on Spaceship One ended with a wonderful party in St. Louis. And I have this picture of Paul and I holding up a check that's about 8 feet wide that says $10 million on it. Imagine getting 40% of your investment back by flying a couple more flights. That just doesn't happen in aerospace research nowadays. And Paul was nice enough to share half of that money with Scaled Composites. And it was so neat to be able to go and pass out some of that money to every one of my employees. Now, that kind of relationship means that you beg to work with this man sometime in the future. And I'm so happy that I'm able to do that. And I'm so happy to be able to call you my friend, Paul. Thank you.
Thank you, Bert. Bert is a cornerstone of our Stratolaunch Board of Directors, and we are fortunate that he has helped us assemble a truly amazing group of industry leaders who will help lead this initiative. I'd like to take a moment to introduce another member of our Board of Directors who Bert just introduced as well, Mr. Mike Griffin. Mike was nominated by President George Bush to become the 11th Chief Administrator of NASA. As administrator, he led the NASA team and managed its resources to advance the U.S. vision for space exploration from 2005 to 2009. Prior to being nominated as NASA administrator, Griffin served as Space Department head at Johns Hopkins University's Applied Physics Laboratory and served as CEO of Orbital Sciences Corporation's Magellan Systems Division. More recently, Mike has been in the position of eminent scholar and a professor of mechanical and aerospace engineering at the University of Alabama in Huntsville. It is my pleasure to invite Mr. Mike Griffin to the podium.
Thanks, Chris. Now you all have to listen while I do the mandatory microphone adjustment for shorter guys. Well, thanks, Bert. You know, I have been called many or had many allusions to various aspects of my character over the years, but risk-averse, being risk-averse was never on that list. So now wouldn't be the time either, and I loved your feathered entry vehicle concept. I thought it was quite good. I'm not going to say anything about software or money with Paul Allen at the table, and I'm not going to say anything about airplanes with Bert Rutan at the table, but I will make a couple of comments about commercial space. Those of us who have spent our lives and our careers, and in my case 40 plus years to this point, in the aerospace business know very well that it is a business, especially in the space side, dominated by government efforts, government program, government funding. It has achieved in the civil, military, intelligence community sectors results, as Paul was saying, that have made us the envy of the world up until we stopped doing it. But no one looks at any sort of government program and expects efficiency to be one of the watchwords of such a program. Government programs have gotten results that, as I say, have stunned the world, but they don't come on the cheap. They're not efficient. And we don't expect it to be that way, really. We make jokes about it. You know, I'm from the government, here to help you, things like that. Those are jokes for a reason. So all of us who have spent our lives in the space business have looked for, hoped for, sought out opportunities to bring the component of efficiency to the effort. And I think all of us who have been in the business know that that can only come when there can be a substantive commercial effort. What's been in the way of that? There are structural factors. It takes a long time, even for experts, to do anything in the space business. Paul said by the end of this decade we'll be doing things. I hope it'll be sooner than that, but he knows it won't be soon. It takes a lot of money, and it takes a steadfast commitment to fly through the inevitable development failures which must occur. About 30% of the first 10 rockets of any particular type that are built wind up not making it to orbit. That's a historical average over 60 years, and it doesn't matter who's doing the building. So it's a chancy business, and it's hard to get it right. So to have a successful commercial space effort requires vision. It certainly requires solid financial backing. It requires the courage to fly through failure to get to success. And of course, it requires great vision and technical talent. Those things, those latter things, are not in short supply in America, but the kind of commitment, sustainable commitment that Paul Allen brings to this enterprise and the kind of vision that Bert brings to this enterprise are in short supply and are rarely combined. So for that reason, I was pleased to be invited and pleased to be able to accept the request to join this board. So thanks to both of you, and thanks to all of you for being here.
Thank you, Mike. So before we open the panel to questions, I'd like to introduce a few additional people who will be critical to Stratolaunch's success. Leading Stratolaunch Systems as CEO is Gary Wentz. Gary, could you raise your hand? Prior to joining our team, Gary served as the Chief Engineer of Science and Mission Systems at the Marshall Space Flight Center in Huntsville, Alabama. His tenure at NASA ran from 1993 to 2010, and during that period, Gary filled a variety of leadership roles. As an engineer, Gary was responsible for the integration and test of hardware on the International Space Station, as well as the preparation of various experiments to fly on board the Space Shuttle. And Gary, if you could, I'd like to invite you to come join the panel, if you could come on up. While Gary makes his way up, I'd like to also recognize a few other people that are here this morning. Jody Allen, Vulcan's CEO, is joining us. Thank you for being here today. I'd also like to mention Paul Ghaffari, our Chief Investment Officer at Vulcan, who's been very helpful in getting all of this set up. We have other board members in the audience. Dave King, who serves on our board of directors, is the Executive Vice President of Dynetics. Dave is here. Doug Shane is also here today. Doug, hand. Doug is the president of Scaled Composites. Interestingly, he was the first engineer hired by Bert when Scaled opened in 1982. Gwen Shotwell is the president of SpaceX, another one of our partners, also a member of the board of directors. Unfortunately, Gwen was unable to make it here today, but Adam Harris, VP of Business Development, Adam is over here, is here today too. And then lastly, before we turn it over to the panel, I want to introduce Jim Halsell. He's Stratolaunch's technical director. He's right over here. Jim is a former NASA astronaut, and he's a veteran of 5 space shuttle missions. So welcome all of you. Thank you for being here today. So now we're going to do a Q&A. We've got folks dialed in on a teleconference, and if things are going well here, they're going to be emailing questions to me. So what we'll do is start with the folks that are actually in the audience today. I'll point, if you could ask your question, and then we'll go to the emails afterwards. There's only a few emails that have come in so far, so we'll stick with the audience until we get a couple that we can go to on the email. So yes. And by the way, I'm going to repeat these too so the folks who dialed in can hear the question. The question was, could you tell us more about the business model? Gary?
So Stratolaunch is set up as an individual corporation that's working with 3 partners, Scaled Composites to build the carrier aircraft, SpaceX will provide the launch vehicle, and Dynetics out of Huntsville, Alabama will provide the mating and integration system. Our intent is to build the aircraft in Mojave, at the Mojave Air and Spaceport. Hawthorne will be used as a manufacturing facility for the rocket, and the mating and integration system will be built in Huntsville, Alabama at Dynetics' new facility. Then we'll proceed to conduct a lot of the flight testing out of Mojave Air and Spaceport, and right now we're in discussions on where our actual launch point will be. So we've done a market analysis, and we believe that we will be able to offer an affordable solution for medium-class payloads.
So let me answer the question here. The question was, how much money do we expect to put into this?
Obviously, this is not inexpensive. It's an effort of this magnitude is going to end up costing at least an order of magnitude more than I put into Spaceship One. But we're not going to say, we're not going to give an exact figure today. And I think the unique thing about the approach here that people should understand is, obviously we've got a lot of experience in our team. We're taking components, proven components from a number of different providers, doing a full systems integration. So we're using the composite experience of Scaled, SpaceX's proven booster capability, and then we're integrating all that together. So we're not, obviously there's a lot of challenges to address and technical things to prove out, because a system of this size and this scale with these different elements, it hasn't been done before. But we're using proven technology as the components, and parts from 2 747s. The engines are 747 engines, for example. So it's a lot of proven technology going into our approach. So it's different from programs where you have to start from scratch.
I've got one coming in now from the folks dialed in. The question is, why is this a better way to launch humans and cargo into orbit than a standard rocket? And they wanted to direct it to either Mike or Bert.
Well, I'll start. I don't know that it's a better way. It's an approach which has a long history. We've been airdropping manned rockets since Chuck Yeager broke the sound barrier in October of 1947 in the Bell X-1. It's an approach which offers some very substantial operational flexibility, much reduced range requirements, freedom from a lot of the limitations that come from launching with land-based ranges, the ability to deal with weather scenarios that we can't when we're parked at Vandenberg or the Cape, and it offers some limitations. The payloads will have trouble growing. The airplane is as big as the airplane is, so it has its pluses and minuses. It's a little bit different than what folks are used to seeing if you watch a rocket launch on television, but it is, as Bert was indicating in his remarks earlier, not a new concept. It's not untried, and it's one that we think will offer some significant operational efficiencies.
Great, thanks. Yes.
I may comment just a little bit on the performance of an air launch versus a ground launch. If you're doing what you're doing with Spaceship One, and that is just going to 100 kilometers or 130 kilometers for a brief suborbital space flight, air launch is an absolutely huge difference. The size of the weight and the impulse that the rocket has to have for a given payload is only about a third as big if you air launch. However, if you're going to orbit, the performance advantages is only about 5 or 10%. So 5 or 10%, does that justify building an airplane to do it? Of course, while you're getting all the other advantages of point and shoot from anywhere you want. 5 or 10% in the orbital business is also huge. If our Earth were a little bit heavier, bigger, and we were limited to the same propellants, we would have not yet gone to orbit. If it was a little smaller, we could have done it much cheaper and so on. But anyway, it's a small advantage when you're going to orbit to air launch, but it's in a world where a small advantage is actually big.
Yes.
Are those three partners who are building the different parts of it, are they putting in their own investment, or is all the money coming from Stratolaunch?
Let me repeat the question. Are the three partners that are involved with the Stratolaunch Systems project putting any of their investment into the project, or is it being driven by Paul Allen's investment?
No, they're all subcontractors to our effort.
Mr. Allen, there's an old joke in aviation that if you want to become a millionaire with an airline, you start off as a billionaire. This seems like a fact.
They say that about yachts too. There's some correlation there, maybe.
Could this be a fast track to that kind of scenario?
No, this is a big, obviously a big initial investment that we wouldn't be making if we didn't think there are going to be a lot of customers out there, both for cargo and for manned missions in the future. So it is a big initial fixed investment to get this going and see this development program through. But you have a certain number of dreams in your life that you want to fulfill, and this is a dream that I'm very excited about seeing come to fruition.
Is the main thing to make money or to develop space exploration?
Well, I think if you've seen what the Russians are charging, I think it's north of 60 million. 60 million a seat.
63 million a seat currently.
63 million a
for
seat.
NASA.
So if you can come up with which we believe we can, a manned version of this, it can be very, very competitive with those kinds of fees.
Great. Bill?
Yeah, hi. Two questions for me. Bert, can you provide a little bit more info on the airplane? You mentioned the legacy parts or established things you're using in the building your own design. Just some additional details about that. For Mike Griffin, Mike, you've said in the past that you've been critical of the commercial effort at NASA. Because of the business model case, nobody understands how folks are going to make money doing that. You kind of answered my question in your remarks, but could you expand
First of all, you
Bert,
mentioned...
hang on, let me just repeat the question so the folks out there can hear it. The first question was pointed to Bert, just giving a few additional technical details on the air launch system, and then we'll do a follow-up one with Mike, expanding a little bit more about why this particular space is a compelling space to do business in.
Well, first of all, you said my design. I'd like to take this opportunity to clarify, like I have been for the last 10 years or so. I did design the Spaceship One system. I did not design the step-up system. That was done, is being done by younger folk than I at Scaled Composites, and they're the ones that should be getting the credit. The Jim Tighes and Bob Morgans and so on should be getting the credit as the designers of those airplanes. I did concept work myself and preliminary design work myself for the last 23 years or so on these things, and the last 20 years since that Houston meeting. However, I'm not the responsible designer. I've actually retired. I don't even show up at work anymore. So I would like to see those that are designing this airplane get the appropriate credit for that. Can I give you more details about the airplane? I would prefer not to. If we were rolling this out and ready to fly, like when we unveiled Paul's first program, we would be years ahead of any competition. I don't think it's wise at this program because we are announcing it very early. I don't think it's wise for us to give the competition our technical numbers. I would prefer that they can guess those, but it doesn't make sense to me that we would share our technical information with folk who might be competitors of ours until we have to share it. And we have to share it after it's flying, but we don't have to now.
And then Mike?
Yeah, thanks, Bill. That's, I think, a good question. You note correctly that I have been critical of some so-called commercial efforts when sponsored by government, if and when those commercial efforts receive money in advance of performance. When the government chooses to procure goods and services that the market doesn't furnish, and does that through what we call negotiated or prime contracts, there are very careful selection criteria, rules, and procedures for awarding that money to eliminate the concern that government is picking winners, if you will, in the marketplace. And when I don't see that, I become concerned. So that doesn't apply here. Why do I think this venture can be a success? Well, as I indicated in my opening remarks, I think the crucial factors for any putative commercial space venture are the necessary financial wherewithal to sustain what will inevitably be a lengthy development process relative to other typical market items, and the vision and the resolve to fly through the developmental failures which inevitably occur. And I think Paul Allen has demonstrated already through his personal history both of those qualities. I think that makes the crucial difference. In the end, the business case will be dominated by the long-run market, and I think it remains for all of us to see what the market for space transportation could be when the operations are more cost-effective.
Let's go to the back of the room.
Do you have any comment on the booster itself? It looks something like the proposed Falcon 5. I think 5 engine design or shorter. Do you have any commentary on which Merlin engine they're using or just some of the characteristics?
The question was, can we get some comment on the technical elements or the specifications associated with the Falcon short engine that we're going to be, or rocket booster that we're going to be using?
So the current concept that we have in development is a Falcon derivative launch vehicle. It will either be along the lines of a Falcon 4 or a Falcon 5, and that'll be driven by our performance trades that we're in the process of executing. It will be shorter than the existing Falcon 9 vehicle, and we're currently running trades to determine what kind of wings or fins it may need to actually make the turn from the drop to ascending to orbit. We don't have that in the current design, but that is something that we would consider over the next several years.
Yes?
Could you tell us a bit about how far along you are in the design of the plane, and given the fact that we've seen a lot of new airplane programs here lately that have been massively behind schedule and over budget, what your expectation is about the timeframe going forward?
So the question is, can we get a sense for where we are in our schedule now and what our expectations are for schedule going forward?
Yeah, you ask where we are in the design. I would just say that this is not a preliminary design at this point. It's we over the last 10 years or so have done a lot of preliminary designs. There are detailed structural analysis, detailed CAD drawings, detailed analysis, sizing of this. This is not a sketch. It exists in hundreds of detailed drawings, and it's relatively close to building as soon as we can get a building big enough.
Gary, do you want to add a couple of comments on that?
So, as far as the aircraft goes, we've started construction of a hangar in Mojave. As Bert said, the design does exist. We are looking at different trades of how we would alter the design to meet the system requirements that we have. We also have already led a contract to acquire the two 747s, and we've identified the components that we will be using to integrate with this aircraft. That's correct.
And, I'll add onto the question, because it just popped in here and it's very related just to this particular stream of thought. Any sense for first test flight? When are commercial operations expected? Longer term schedule?
So currently what we're looking at is conducting our initial test flights of the aircraft in the 2015 timeframe with an initial launch in the 2016 timeframe.
The question is, what do we see as the largest revenue stream, government, private, et cetera?
Well, at this point, that remains to be determined, but initially, there is a thriving communications satellite market for small to medium-class communications satellites. This would make a very effective launcher for such things. There is an annual market for government, mostly NASA, but some Defense Department, I'll say unmanned scientific satellites of one kind and another that is at least a half a dozen or so a year. This vehicle has a payload capacity very much akin to the old Delta or Delta II performance level, which NASA and the Defense Department have purchased for many years. That vehicle is no longer on the market, so this design fills that niche quite nicely. So there's to try to get to a summary bottom line, there's a lengthy history in commercial defense, NASA civil space markets for payloads in this payload class that we think this vehicle can address.
Paul, there's a question. Go ahead.
There's also almost an unlimited number of payloads that are easily produced by unskilled labor at home that folk that would like to go to orbit as well, too. I don't think there's any limit to that, the number of payloads that would be in that category.
Great. Paul, this is a question for you. It says, this is not the first science or space-related project that you have become involved in. What do you feel is the importance of investing in science, astronomy, and private spaceflight?
Well, I think it's well known that I'm a huge fan of anything that pushes forward the boundaries of what you can do in science and technology. That's my history. Those are my passions. So everything from the Brain Institute to Spaceship One, a new radio telescope that we did in California. So anything that pushes those boundaries and increases our ability to do new things, to me, is an exciting opportunity. And it's been very rewarding for me personally to participate in those things. The Spaceship One and the Brain Institute are just a couple of the other things I've really found the most rewarding to have been able to come into being in the last few years. So I just want to express my excitement about that.
Great. Yeah.
Somebody walked through how a mission works here. You're talking about unmanned payloads. Would you need a manned launcher to launch them? Could they be an unmanned launcher to launch them that you're carrying out? When you take people up, what kind of mission do you envision they would be doing? How long might they stay in orbit, etc.? Just walk through this various scenarios and how you think this ain't right.
Okay, so the question was kind of paint a picture of what a mission may look like, what the scenario may look like. Was it specifically manned or unmanned, or just a cargo mission?
Carry cargo to the space station.
Yep.
All that. Walk through these various scenarios.
Well, that's a huge question. I'll try to take a bite out of the apple. I think initially the vision is unmanned payloads that are not cargo to the space station. That's the place to start, because although nothing in this world is easy that I have ever found, that is the easiest. We also, as I indicated with my answer just a moment ago, we know that there is an existing stream of payloads that can be serviced. Now, hopefully, the existence of a more streamlined transportation system will result in the creation of more such payloads, because the ability to put them in orbit becomes affordable. Cargo to the space station is a very rational goal, but NASA has, and the 14 international partners that the United States have some pretty careful strictures on what we call visiting vehicle requirements. You have a space station that cost about $75 billion from all countries involved to put in place, and one wants to see to it that a visiting vehicle does not damage it. That's not an idle concern. There was a crash, is the only term one can use, of a Soyuz spacecraft into the Mir space station some years back. It was and was properly treated as an emergency. So these are not idle concerns. Certainly at some point, and this is not my decision, it's a decision Paul Allen would have to make, there is the capability of this vehicle to loft a medium-sized crew, say 6 people. This vehicle has the inherent capability to do that. Whether they would visit the space station or visit another yet-to-be-developed facility or just go into space for a few days and come back, I think those scenarios are not laid out yet. If they have been laid out, they haven't been laid out in my presence.
Well, when you're doing payloads,
Yes.
medium-sized satellites, Delta-class satellites,
Delta-class satellites.
does that require a man? Is the vision that would be an unmanned launch?
Yes. I mean, there's a crew flying the airplane, but you're not talking about that.
Right. But the launcher itself would be unmanned.
Correct.
It would only become manned when it became a manned orbiter.
It would only become a manned launcher when there is an intent to put people in space, as with that model that you see right there.
When the men or women are the payload.
Yeah.
Any other comment on that one? No. Good.
I just want to ask about
Yep.
personal trips that you envision, such a version
So the question is, when we start doing manned payloads, manned craft, who do we envision those individuals will be initially and over time? And how much will they pay?
We have several people in this audience who have been to orbit. We even have someone here that I believe paid his own way twice. Is that right?
Yeah, I was kidding Charles that if he ever flew again, he should ask for a volume discount.
In the,
Go back up.
In the entire world, we only have one person who has actually paid his own way and returned and paid his own way. That's not a real big number out of 6 or so billion people.
7 billion people.
7 billion people, yeah. The thing that troubles me is that it has become more expensive to put people in orbit with the systems developed by this country than it was the very first year or the very first decade. Statistically, the shuttle was the most dangerous way to fly people to orbit. And to come up with a capability in 1961 and then find out that 50 or so years later that capability costs more and is more dangerous, that's just nonsensical. I believe that there needs to be several real big breakthroughs to make it more affordable and to make it safer so that we can have public access to orbit. And I believe that using air launch might be seen as one of those necessary breakthroughs. The rest of them, they're not breakthroughs until you know about them, until they're discovered. In fact, a breakthrough usually is nonsense until it's considered a breakthrough. So I would love to be able to be out there searching for other breakthroughs so that we can go to orbit more safely and can do it more affordably so that we can have hundreds or thousands or tens of thousands of people able to experience that view. But the only element of that in terms of orbital that I have worked on has been using an airplane for the initial flight out of most of the atmosphere.
Is there a follow-up? The question was to Paul, at what point would you ride one of your own vehicles?
Boy, I mean, obviously we have a long road to getting everything integrated and flying cargo. Once we go past cargo, I'm very excited about the manned options here, and that's one of the primary things that gets me so excited about this, and the safety factors that Burt Rutan talked about. An approach like this gives you extra safety margin. You want to talk about that?
Yeah, well, there are 2 unoccupied seats in the back of Spaceship One, and somewhere in storage is another rocket motor for it. Maybe you and I could, maybe we could talk the museum and letting us use it for a week or so.
And obviously, Virgin is going to be flying people in the not too distant future in suborbital flights. Personally, I think I'm going to wait for a large number of those flights to happen before I'll think about it. I'm actually a fairly conservative guy in some aspects. That might be surprising.
Great. Here's a question from the folks dialed in. Would you consider configuring the carrier ship to launch some other booster or perhaps a rocket plane like the ones made by Sierra Nevada Corporation?
Well, the carrier aircraft is restricted to carrying something in the neighborhood of 500,000 pounds, and the Sierra Nevada crew vehicle requires, the last time I checked, something a good bit bigger than that. So I'm not sure that fits within the technical range of possibilities. but certainly the carrier aircraft could carry more than one type of rocket, and I think we just have to leave that for the future.
Well, the beauty of a large turbofan airplane is it really meets the definition of reusability. The rocket people tend to say reusability applies to the shuttle, even though they run the engines only for 5 or 10 flights. Is that right?
Well, and actually we had to tear them down and put them back together again after every flight.
Every flight, and that's reusable. Well, taking stuff, all the systems on this big beast. By the way, a 747 is about this much wingspan. Taking all that stuff is the very best definition of reusability is a turbofan airliner, because you take a typical 747 throughout its entire life, it spends somewhere between 12 or 15 hours a day airborne.
All right. Yes.
I wanted to ask about the competitive environment. You've got a lot of people, for example, SpaceX, Scale Composites, who are involved in other projects. There's talk about how air launched is cheaper than ground launched. How do you negotiate all these potential competitors who are suddenly going to be partners of yours?
So the question was, how do we navigate the competitive environment that we exist in with the people who are actually partnering with us on this project as well?
Well, I talked to Elon yesterday, Elon Musk, and he's very, very excited to be participating in this project with us. We're really looking at it. They're building some from very, they're even scaling up their rockets. They're looking at even bigger payloads. We're in a different class of payload size. Do you want to talk about that?
Sure. So the Falcon derivative that we're actually building is focused on, as you saw in the video, 13,500 pounds, which is significantly smaller than the existing Falcon 9 vehicle. So when you look at it from a SpaceX perspective, this is actually a complementary capability to their existing design. Paul talked about earlier that we're actually leveraging a lot of technology that our co-contractor team has come up with. In SpaceX's design, we're actually using the Merlin engines. So those have been developed. We're staying with a common core diameter so we can utilize all the same tooling and things like that. So from a SpaceX perspective, it's not a competition within the SpaceX. It's actually a complementary capability.
So we're going to take one more question. Yes.
Should we think of this as a cargo business? You're starting with a single plane, or is it a cargo business you're starting to subsidize the aircraft manufacturing business? Will we see multiple craft going on in the future?
So the question is, should we view this as a cargo business with a single plane, or may we be creating multiple carrier vehicles over time?
Well, I think that would be based on demand, and obviously the hallmark of this approach is there's an amazing amount of flexibility to fly multiple payloads in a short period of time, and from different locations and different orbits and different kinds of payloads. So if there was sufficient demand, we could see our way to building more carrier aircraft, but that's a long ways down the road.
Okay, so I said that was the last question, but the panel and the members of the board and the folks that I introduced earlier are going to be around here for a number of minutes after we wrap up. So I think there's probably time, for those of you who have some follow-up questions to meet with them. Again, I want to thank everybody for
Thanks everybody
for joining us
today.
Exciting day.
It's very exciting.
One other thing. Don't worry about it.